First lesson we're going to discuss is wind shear. Wind shear is basically a change in wind speed or wind direction with height. So think about this. You have an aircraft coming in for a landing at 300 feet off the ground. There's 30 knots of wind, and there's 20, 10, 5, 2. So you can see there's a significant drop in wind speed as you're coming into land here, even though you're going into the wind all the way. That's going to make a major difference on your performance of your aircraft as it's coming down to the landing zone. Microbursts, on the other hand, have wind shear in all kind of strange directions. So you might be coming with a good headwind, and all of a sudden you have a very strong tailwind. And that's caused more than one crash, unfortunately. So it's something to always be concerned with on wind shear. So moving on throughout the book here a little bit, we talk about microbursts because they are a major issue, and sometimes you don't even have precip in them. The clouds may be just developing, and the precip hasn't really formed yet, or just beginning to form. Maybe it's outside the line of your flight into the airport. But outflows out of them could go pretty far out. Shelf clouds are basically where the air is. Remember, we talked about a thunderstorm that has a great inflow of air upwards and a whole bunch coming downwards. When that downwards hit the ground, you get that downburst. And it may be weak or it may be strong. One of the interesting things is that you've got rain shafts on your column, on these thunderstorms. You might be able to see a direction on the rain shaft. Maybe they bow out both ways. You have a much better look at it aloft than you would at the surface, obviously. So maybe you can actually see them bow way out. Sometimes you get these shafts that go way out many, many miles, it seems like, ahead of the main thunderstorm. Think about all the wind that's pushing that outward. It's coming down, hitting the ground, and pushing out. This outflow is much, much further out, and maybe the rain shaft is coming out with it. So these are all observations you can make when you're flying, or even before you take off from the land. So, but microbursts definitely cause an axis. There's always spinning at the edges of them, which can generate dust upwards into the clouds. So again, another thing to watch for, because you may be coming in through this section, you get 3 to 4 different wind directions and speeds to deal with. So move along here a little bit more. Really not much in that section. I wanted that way. But think about, let's take a look right now about wind shear. If you saw this pattern, you would see big high pressure off the east coast, east winds. Pretty doggone strong high coming down into the Midwest. Northwest winds here, northerly winds. So where would you expect to find wind shear? So we know there's going to be some thunderstorms out ahead of this cold front. So that's the area you're going to be dealing with downburst potential from thunderstorms. But what else? Well, take a look at this morning sounding at Dodge City, Kansas. If you're flying into Dodge City today, the cold front that we just looked at here, here's Dodge City back up in here. It's fairly far down here, but it's only about 700 millibars deep. So if you were flying up in this altitude, say about 10,000 feet, you'd have a nice westerly wind. But as soon as you drop below that altitude, the winds are going to drop and they're going to turn northerly. So that is something to think about as you hit an approach into Dodge City today. So you can see wind shear can occur behind or before a front. It could also occur, if you look at this low right here, think about this. There's a lot of nice, warm, southerly air here. But remember, the warm air likes to go aloft as well. So the potential for wind shear up here in southern Canada could be fairly high because you might have a fairly strong southerly jet moving along that would be causing this issue. So just wanted you to see that. Hope you got something from that.